Okay, last chapter for the book. And this book, some parts I really enjoyed, but the data is prepared. Compared to one book we're going to go next is we're going to prepare data and start a lot of things from scratch, and also we will have to prepare our own data. But this book, most of the time the data is prepared for us. So but for the future reference, that we're going to learn how to prepare data, and how to download data and how to share data from ArcGIS Online. So we're going to use different books, and we will learn from different perspectives, and we will gain different experiences for ArcGIS Pro. Alright. Okay. Now, we will continue. So this is still part 4 for managing systems with GIS and optimum routing. That's the first one we're gonna do. Prototypical problem and inputs. So traveling salesman problem, TSP. Salesperson starts a day's stops with customers from office or homes, visits all customers and returns to office or home. Problem. So determine the sequence of stops to minimize travel distances or travel time. The case is routing to remove graffiti from several locations in a work shift is an example of a TSP, the travel salesman problem. So inputs must have a network data set with streets, allowable terms, and average travel speeds for each street segment. So point feature classes for starting point, ending point if different from starting point, and stops. Network analysis tools for routing in ArcGIS Pro. Heuristic solution for TSP. Combinatorial optimization problem. Example of several problem types that cannot have guaranteed optimal solutions with today's computing capacity. Instead, use a heuristic solution procedure that finds very good solutions. So Heugestra's shortest path algorithm in 1959 finds shortest path from starting location S to destination D through network. So original destination OD matrix, shortest path between all origins and destinations. So traveling salesman solution uses OD matrix and a taboo search heuristic, starts with an initial solution and attempts to improve by substituting nearby stops to each stop. Once the substitution fails to improve, it is marked taboo and not tried again. So the graffiti data for scheduling removal. The first one, graffiti features class data schema. Originals, the fields from 311. So let's look at what data they collected there. So there are 4 fields here. First is request ID, primary key identifier in 311 system. Address of graffiti site, date _ call, date graffiti call made to 311, X and Y longitude and latitude of address. Fields added for operations management, date approved to remove, and date scheduled for removal, and date terminated, date call terminated without removal, date finished, date graffiti removal, removal type code method for removals, solvent, sandblast, etc. Graffiti type code, type of graffiti, tag, throw up, etc. and time, work time estimate, removable work time estimated by supervisor, work time actual removal time, artist tag or moniker. So maintaining master graffiti feature class. Suppose new graffiti data is exported from 311 for adding to existing graffiti feature class. Then needed steps and geoprocessing tools include add new fields, as in previous slide. Add field tool, use geoprocessing tools to make feature class with desired projected spatial coordinates, make XY event layer and project tools, append new data to old data, append tool or merge tool. Chapter 13 does not use above steps. Instead, provides the updated graffiti feature class ready for use. Building model builder model with about 3 steps is a good supplemental exercise not assigned in chapter here. So workflow for graffiti removal. They have the workflow. So new graffiti volume is low enough to allow scheduling for removal once a week and only a few routes per week. Maintaining graffiti data, as in previous slides, we need model builder model. So public works supervisor visits each new graffiti site to make assessments once per week, approves graffiti for removal, terminates response to removal request. Example, cannot locate graffiti on private property and permission not granted to remove, etc. And selects graffiti type code, graffiti removal type code, enters graffiti artist tag if recognized, estimates and enters work time for removal minutes, will implement with collectors for ArcGIS. So we did collectors before. It was fun, and the issue is you have to be very careful. If not, it will not show up in your collector in your cell phone. So workflow for the graffiti removal tool is number 3 for supervisor schedules one or more routes for removal once per week, views map with approved graffiti calls needing removal, using map and judgment, selects graffiti sites for a route up to 480 minutes of travel and work time for the graffiti removal employee in one shift, terms TSP algorithm, views solutions and total time. If route is acceptable, records the route and related fields in graffiti feature class and driving instructions. If not acceptable or more graffiti sites remain to be scheduled, starts back at item alpha in this list and will implement with model builder models here from tutorial 1 and 2. So the workflow for graffiti removal 3 is the employee who removes graffiti drives route and removes graffiti, gets map of route in driving instructions. I hope they don't use Navigator, because Navigator I don't have access to it. Last time I called the Israeli help desk, it cost like $50 at least to start to use it. Alright, and then at each graffiti site makes corrections to data if needed, so selects a different removal type than one selected by supervisor, removes graffiti, enters actual work time, and enters date when finished. Contingency: if employee who removes graffiti does not complete a route, have to reschedule graffiti not removed, built into graffiti data schema as seen later here. So now the first one part is identify graffiti removal. And we will create a map that, starting this map, has graffiti costs appended to historic data. Query finish map. So has graffiti removed for removal symbolized and labeled by estimated removal work time minutes. So query expressions for map on previous slide. So the cases to handle connected by or graffiti costs that have been approved for removal by the public works supervisor but have not yet been scheduled for removal. Date approved is not null and date schedule is null. Graffiti costs that were previously scheduled but were not removed as scheduled. Current date gets the current date from the computer calendar. So date schedule, current date in date finished is null. So let's look at the model that identify graffiti for removal model. So we include query from previous slide. So like here, we're making any output map layer a parameter, forces the layer to be added to the contents pane when module run to provide user interface. Last time we used it. Symbolized graffiti for removal using a layer file for unique values with labeling. So this is the interactive selection of graffiti sites. Supervisor uses expertise and judgment to select graffiti sites for removal. And calculate optimal route. That will be interesting. So now we will have a workflow. It's like this. So now we will have prototypical model for traveling sales problem. So create group layer in contents pane with a standard TSP layer for output. Each add location tool adds exist point, feature class starting point garage, then cause graffiti cause for removal, and finally ending point garage. Solve RUM's optimization model. That's really cool. So optimal route. So if supervisor does not like the route, she can remove route from the contents pane, select a different collection of graffiti sites, and run model B again. So if she likes the route, but there are graffiti sites not included from graffiti for removal, she can select them and run model B again to create a second route for the week. Otherwise, remaining sites can wait until next week. Garage starting and end point. So the record route results. So the purpose of this model, this is really a cool model. I really like it, so I'm very excited. The purpose of this model, giving a route that the supervisor wants to keep, save driving instructions for the route, save the route as a feature class with a name that includes the schedule date route 2016 June 13, write the route name and schedule date in the graffiti calls master feature class. So inline substitution allows users to input parameter values into model, create a variable route name and make it a parameter. The P, the user is promoted to input the variable. We will type 2016 June 13th for its value when running the model. When needed to use the route name's value, include surrounded with % signs. So that we learn in JS2, the labs. So which is really cool. Feature class versus map layer. So graffiti class is a feature class stored in the here it's a file geodatabase. Graffiti class for removal is a map layer in the contents pane of a map created by querying graffiti calls. Any changes made to attributes of graffiti calls for removal are saved in the feature class graffiti calls. And then we will do is record routes results model. So we have a route, direction, and we will copy feature, calculate field. So writes term by term driving instruction in route 2016 June 13th text file, create feature class for route called route 10060613 and writes route name in graffiti calls, writes day schedule in graffiti calls, and calculate field code blocks. So here, if we see the code blocks import datetime, we define get date, the date. So we have this. Okay, I think let's see. Route name is a text variable that stores the scheduled date input by the user. So the text value needed for writing route name. Text value needs to be converted to date data type, which requires Python scripting language code blocks. So I thought it's Python import something. And sends the text value route name as input to the get date code block. And code block reformats the value to be date value, which is stored in date schedule. And collector, ArcGIS collector that we have to download this app. I already have it in my cell phone. So we can my cell phone iPhone 6s Plus. So we just have to log into the Israel account. Maps must be configured for collector in ArcGIS Pro and stored in ArcGIS Online with configuration for collector as well. So capabilities collects and updates location, including the current location and attribute data in the field. Uses online or offline sync changes when connected, captures and shares photos or videos. I still have to share photos or videos. I have to explore that function. Hopefully here it will mention here. If it does, that will be perfect. If he can provide the share photo function here in the tutorial here. And use collector by supervisor. Views map of all graffiti colors that are new and need supervisor's view review.